a quiz for that later on, but first I have to mark it and get it back to you, and then we got to do the outline and stuff. So that'll be next week probably. Okay. So there's that coming up, but we're going to move ahead in the identities area. This is our final area. There are probably 8 to 9 days, so 2 weeks. So somewhere in December, right before Christmas, we should be done. We're in the final week of November. There's 3 weeks almost in December, so we should finish no problem, with the exception of the final. When we come back after our break, we are going to take that time and get ready for the final exam. Okay? All right, so today we're just going to look at the fundamental identities and what an identity is. Okay? So let's start out with what they mean by identity in math. And this basically, we're talking trigonometric identities. Okay? So okay, is our focus in this unit. Okay, and an identity can be defined as an equation that is always true for any value of the variable that is permissible. That's what it is. Okay. So it's just a math expression that works all the time for no matter what number or value you put in, as long as that's not a non-permissible value like a negative square root or something like that. Okay. So there are 8 fundamental identities, trigonometric identities that we work with. So we're going to start with the fundamental identities. Okay, I'm going to use the marker here just because we have to make fractions. So let me switch over here. Okay, so we're going to look at fundamental identities. Okay, so there are 8 of them. Now they're classed into 3 categories. So for trigonometric. So the first set that we're going to look at is called the reciprocal identities. Okay, so these are always true. So the first one is cosecant. That's equal to 1 over sine x. Now the x can be any variable. Okay, and then we have the secant one. That's going to equal 1 over cosine. And our final trigonometric identity is the cotan one. Okay, now if you rearrange these, if we bring this over here and then divide by cotan, the opposite is also true. These can be rearranged.
Mr. E, for cotan, shouldn't it be tangent instead of cosine?
Oh, you're correct. What am I doing? Oh, you can stick my sticker pack is right by the door there. You can grab one and put it on the wall. You're right, this should be tangent. So you can put so if you grab a sticker, I just put my sticker thing. See where the water bottle or
Yeah.
that is? It's up there. Why did I put it up there? Because when I put it in my desk, I lose it. All right, yes, it should be tangent, obviously. Cotan and tangent. Okay, so you can rearrange these as well. Also, it could be like the sine could be over here and the cosine could be here. They could be switched around as well. But those are the 3 reciprocal identities. Okay, we're familiar with that from the very beginnings of the course a little bit. Okay, then there's the quotient identity. There are two of those. Okay, quotient identities. Okay, so quotient identities are tangent and cotangent identities. So tangent of some variable, we'll say x, we'll stick with x. Okay, that's equal to sine x over cosine x. And then obviously if we take cotan, it's the opposite of that. So cotangent x would equal cosine x over sine x. So those two fundamental identities are known as quotient identities. Okay, and obviously these are all trig identities. Okay, and then we have the Pythagorean identities. This is the last section of trig identities that we're going to look at. And there's 3 of them. So there's 8 of these. There's 3 reciprocal identities, 2 quotient identities, and 3 Pythagorean identities. So I'm just going to move that up to the top here. And Pythagorean identities. So these ones are called Pythagorean. Okay, now these identities are based on squared terms. Okay, the base one is sine and cosine. So if you take sine squared x and you add it to cosine squared x, that is equal to 1. Okay, so that's the base one. And then you can do the same thing with cotan and cosecant. Okay, but it's a little bit different. Cotan squared x plus the 1 equals cosecant squared x. Okay, and then there's one for tangent as well. Tan squared x plus 1 equals our secant squared x. Okay, so these can be rearranged in any way. This can be rearranged, this can be rearranged, these can be rearranged. But those are the standard fundamental identities. Okay, so these in our text, these are outlined on page 291 as well. Okay, so there's our identities. Okay, so we're going to work with these 8 fundamental identities. That's the beginnings of our identities unit. These 3 reciprocal identities, 2 quotient identities, and 3 Pythagorean identities. So that means that for any value, and these work in both in degrees or radians. But if you're in degrees, you have to stay in degrees. If you're in radians, you have to stay in radians when you're working with these particular types of examples. So the first thing we're going to look at is verifying trig expressions and simplifying them down to see if they're true. Okay, so that's the first type of question that shows up in this area with our values here. Okay, so we're going to have this list in front of us, and we're going to use it. So The very first example that we're going to look at, and let me type this one in a little bit. Okay, so the first type of question that shows up in this section, this is chapter 6, I think, or whatever. So we're going to be looking at how to verify a given identity. For a certain result. Okay, so the first thing you want to probably do we'll say for a value of the variable. Okay, so hopefully you still have your unit circle from way back at the beginning of the course, because we use that again when we have to look up values in it. Okay, so think unit circle. Okay, if you don't have that, you can go back. It's on the Moodle or on the page for our classroom, and you can print it out. If you do have it, you can dig it back out as well. Okay, so we'll do an example here. Okay, so let's say that my identity that I have is I'll use the marker because I got to write a bunch of fractions here. Okay, let's go with red here. So let's say that we're going to verify that cosecant x over 10x plus cotan x is equal to cosecant x, or cosine x. For x equal 60 degrees. Okay? So this is the general verification that we're going to use. So we're going to use the fundamental identities to simplify the left side down and the right side down using the values that we have for x and y and r based on 60 degrees on the unit circle. So the strategy is we're going to plug in our values for 60 degrees and simplify both sides. And see if they're equal. Okay, so that's kind of what we're going to try to do here. Okay, and we're going to use some identities. Okay, cosecant isn't on the unit circle, tangent isn't on the unit circle, and cotangent isn't on the unit circle. So we're going to use the identities to convert cosecant, tan, and cotan x into sine and cosine. Okay? Because what's on the unit circle is sine and cosine. Right? Okay, so if we look at cosecant x is a reciprocal identity. Okay? That's 1 over sine. So we can we can start simplifying this one. So this one here, that's 1 over sine x. Okay, now tangent is the quotient identity. It's sine, well, actually we can put 60 in because we're using 60 degrees. So rather than x, let's put our 60 in. Instead of putting an x, because we have a value. Okay, this is going to be, the quotient identity is sine over cosine for tangent. So this would be sine 60 over cosine 60. Plus, the other one is cosine 60 over sine 60. Okay, so that's all reduced. And then cosine is already on the unit circle. So we can just leave it as cosine 60. Okay, now what we're going to do is we're going to look up, these are all degrees, by the way, because it's not in radians, it's in degrees. So now we're going to look up the value of sine 60, cosine 60, and plug in their values. So if you look up sine 60 on your unit circle, what's sine of 60 degrees? Who's got one in front of him? What do you got? What's sine 60?
Pi over 3.
Pi over 1?
3?
Over root 3? Or is it 3?
Just 3.
Look for 60 there. And then look for sine is the first one, cosine is the second one. What is the first one?
Oh, first one is 1 over 2.
So 1 over 2. Okay? So if we have 1 over sine 60, so sine 60, what's cosine 60? Here, I'll actually, to make it, here, let me help you out. Just so I'll show it here. Let's bring up the unit circle from, let me bring up a unit circle from the page so everybody can see it here. Just otherwise I'll confuse more people. So I'll open the classroom here and I'll just bring it up from before. Okay, so in our first unit we had, where is it here? Where is the unit circle? Right. View more. Right there. Okay, so let me bring this up. All right, so here's our unit circle. Right here. Okay, and then 60 degrees is right here. So cosine is 1/2, and sine is root 3 over 2. See, cosine's the first one, 1/2, and then sine is, there's 60 degrees, root 3 over 2. So our two values are 1/2 for cosine and root 3 over 2 for sine. So this one here equals root 3 over 2, and this one equals 1/2. Okay, so there, and now that we have our values, we're now going to plug them in and simplify our results down to see if they're equal. Okay, so let's do that. Okay, let's go back here, put that up at the top. Okay, 1 over sine 60 is root 3 over 2, so 1 over root 3 over 2 divided by, okay, sine 60 is root 3 over 2 divided by cosine 1/2 plus, okay, cosine is 1/2 over root 3 over 2. Okay, and then cosine 60 is just 1/2. So somehow this is going to reduce down to 1/2 if it's true. So we're going to do each of these reductions So basically, we're going to do fractions, basically. Okay? So let's do this one here. Now I'm going to work out each of these in a different color, green. Okay, so this one is 1 over root 3 over 2. So this is like, when you're dividing by a fraction, you multiply by the reciprocal. So this is 1 times 2 over root 3. That's 2 over root 3. Okay? Now, we can't leave a root on the bottom of an expression, so we have to multiply by root 3 over root 3 to rationalize it. So the top becomes 2 root 3 over 3. Root 3 times root 3 is root 9, which is 3. Because root 9, square root of 9 is 3. Okay, so that's the top. Okay, now we're going to reduce this one underneath here. Okay, so I'm going to take root 3 over 2, and I'm going to multiply it by the reciprocal of 1/2. Reciprocal of 1/2 is 2 over 1. Okay, so the 2's cancel out, and we're left with root 3. Okay, we're going to do the same thing for the other one. Okay, we're going to take 1/2, and we're going to multiply by 2 over root 3. So this is 1 over root 3. So we're going to rationalize that. So this equals root 3 over 3. Okay, this doesn't change. Okay, so this is our answer there. This is our answer there. So this is going to go there. This is going to go there. So, and this is going to go on top. So now I'm going to rewrite this one over these two added together. Okay? Okay, we already know what the top is, so we'll write the top down first. So we got 2 root 3 over 3. Okay, that's the top. Then we'll slide this up a little bit, and now we're going to write the two bottoms here. Over root 3 plus 3, root 3 over 3. Okay, now we have to add these. Okay, so now I'm going to add these two, and I'm going to use a different color to add those ones. So I'm going to add these two together. Now, how do you add fractions? Well, root 3 over 1. Okay, so this, we have to do a common denominator. Okay, the common denominator, if this is root 3 over 1 plus root 3 over 3. What's the common denominator between 1 and 3? 3. So we're going to multiply the first one by 3 and then add it together. So this is going to be, we're going to get that to 3. So it's 3 root 3 over 3. So I just multiplied this by 3 to get 3, just multiplied by 3, multiplied by 3. Both were multiplied by 3, top and bottom. So I didn't change the fraction. I just enlarged it. Plus root 3 over 3. So this is going to equal 4 root 3 over 3. Okay, because this is 3 root 3, 1 root 3. You don't add the bottoms when you're doing fractions, right? You just do common denominator and then add the tops. Okay, so now we have a final expression, and that's, we're going to move this up. We have 2 root 3 over 3 divided by 4 root 3 over 3, and this somehow equals 1/2. And you can see how it's going to work, right? If we take the common denominators out, right, those things can cancel because they're both the same number. We've got 2 over 4 equals 1/2. And this would be 1/2 if we reduce it by dividing by 2. Left side equals right side. So that's our that's how you verify that one. Okay, fairly long. Lots of fractions. But not really any math that's beyond what we've done in the past. It's all just using our unit circle, plugging in our number. So that's called verifying an identity. Okay, you get a specific one. Proving an identity is where you have to do proofs, which we do later in the unit. We don't spend a lot of time on it, but we're going to look at simplifying one in general. So that was our first example. Let's do a second example of verifying. And then we'll do a proof, and then that'll be it for today. We'll do one more of these. Okay, we'll do a simpler one. Let's flip over here. Let's do 1 plus 10 squared x okay, equals secant squared x. Okay, that's, if we look back at the beginning of our course, or today, I mean, if we look back right here, we're just going to verify this identity. For, let's pick an angle, let's say for 135 degrees. Okay, so let me bring my unit circle back up. So, sine 135 and cosine 135. Okay, so if I just got to find my unit circle here again. There it is. Okay, let me slide this over so we can see it. Okay, so 135 is right here, and 1 is a negative root 2 over 2, and the other one is root 2 over 2. So negative root 2 over 2 and root 2 over 2. So we'll put those in. So the cosine is the negative one. And the sine is the root 2 over 2. Okay, so we'll just plug those in. Okay, so if we're looking at tangent, we have to put in the quotient identity and use that. So we're going to go 1 plus sine x over cosine x all squared. Right? Or you could say 135 if you want, because that's what we're going to do. And then secant is 1 over cosine. Okay, now we're going to use these values here. So this would be 1 plus, okay, sine is root 2 over 2. And this other one is negative root 2 over 2. And this one is, cosine is 1 over negative root 2 over 2. Okay? 1 plus negative 1 squared, right? That's just 1. Negative 1, something divided by itself. Okay, and then this one we have to reduce. This is like 1 divided times, this would be like 2 over, sorry, I forgot to square this, right? There's that square. 2 over root 2 negative, and then we got to square it. Right? Because we're bringing this up in here. Okay, so let's square this. So that's going to equal, well, let's just put it in here. Negative 2 over root 2 squared. Okay, so this is 1 plus 1 equals, okay, negative 2 times negative 2 is 4. And root 2 times root 2 is 2. Right? So this is just negative 2 times negative 2, that's 4. And root 2 times root 2 is 2. It's root 4, which is 2. Right? So if you're not sure, root 2 times root 2 equals root 4, which equals 2. Okay? So this is 2 equals 2. So we verified that. So there's 2 examples of verification. Okay? The last thing I want to do today, let's see if I got enough time here. Oh yeah. Okay, the last thing I want to do is do a general verification, one that doesn't use a value, where we just use the identity. And then I'll give you some practice, and that'll be it for today. So let's get my last example out here. Okay, so this would just be a simplification example where we don't have a general idea, or we don't have a value given from the unit circle. So we're not plugging in values. So our last thing is a simplification. Okay, so I don't need the unit circle. So I'm just going to shrink it down. Okay. Okay, so we're just going to do simplifying. So we're going to say, we're going to show that, let's say, secant squared x times cosine x divided by cosecant x is equal to it's equal to, let's say, tan x. Sometimes the book will say simplify to a single ratio. So they might not tell you what it is. They might not say that it's tangent. You just have to simplify it yourself. Okay, so this would be 1 over cosine x squared, because secant is a reciprocal identity, times cosine x. And then cosecant is 1 over sine. So if we simplify this whole side, we should get a tangent. Okay, so we're not going to use a value, we're just going to use canceling. Okay, so this is like cosine over 1. So this would be cosine x over cosine squared x. So that means we can cancel one of them out. And this is still 1 over sine. So if I cancel out that one and this one, that equals 1 over cosine x. Right? Take one cosine off the top, one cosine off the bottom. Okay, so then my result is 1 over cosine x divided by 1 over sine x. Okay, using fractions, take the reciprocal of this and multiply it. 1 over cosine x times sine x over 1. That is sine over cosine. Okay, and then we know that this equals tan x, because that's a quotient identity. Okay, so sometimes they get you to do that type of problem as well. So that's it for examples today. A little bit weird. So this is on page 296, 297. Okay. So for practice, just do 3, 4, and 5. Let me look at that just to make sure that I'm not, it's too complex. So let me just pull that out of here. Let me get my book here. 3, 4, and 5, 297. I haven't looked in here for a while. Yeah, so this is the beginning of chapter 6. 3, 4. Oh, and don't, just do A part of 5. Don't worry about the non-permissible value. So just do A. So 5A part. B part says, what is the non-permissible values? We'll be talking about non-permissible values next day. So that's basically it. You can work on those. I'm going to stop the video at this point. And obviously, I'll mark up once you get your logs in, I'll mark those up, get them back to you. Then we'll talk about our logs quiz once I have those all marked up, and we'll set that up. 2 quizzes to go and 1 final. That's it. A logs quiz, an identities hand-in, an identities quiz. In fact, we might not even put an identities quiz. We might just put it all on the final. So maybe 1 quiz left, 1 hand-in left, and 1 final exam left. We're getting close to the end. Okay, I'm going to stop the video there and let you work on those practice ones there. And I'll